Hi, grade 7. Your assignment for today is lesson 2-1, and it deals with the issue of working with fractions and decimal numbers. If you would please have your math book open to 62 and 63 while we work on some problems, that would be helpful. You'll notice that we're going to be working on the idea of how do we change from a fraction to a decimal or a decimal to a fraction. And so let's get started. When you look at page number 62, they talk about something called rational numbers. Rational numbers are any numbers that you can turn into a fraction. And there's a lot of them. Most of the numbers are rational numbers. Let me give you an example of that. The number 6 is a rational number because I can change it into a fraction. This is the number 6. 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 All of these values equal 6. All of them are fractions. So since I can change 6 into any of these, 6 is a rational number. I can also talk about, say, for example, -5 and call that a rational number because I can make -5 into a lot of different fractions. All of these equal -5. So all of these are rational numbers. I can also take a decimal number, like let's say, for example, 0.4. I can turn 0.4 into a fraction, right? Think about place values. This is called 0.4, but we could also call it 4/10, or if we simplify, 2/5. All of these are the exact same number. I turned it into a fraction, therefore it's a rational number. How about how about a decimal number that's like 2.6? Well, I can do the same thing with 2.6. 2 6/10, which is the same thing as 2 3/5. I got fractions here, so therefore the decimal number 2.6 can be turned into a fraction, and therefore it's rational. All of these are rational numbers. Okay? Anyway, let's see. Oh, go to the top of page 63. Top of page 63 is talking about writing a fraction as a decimal number. How do we do that? They've got their example there of 5/8. And if you look at it, all they did was take the 5 and divide by 8 and turn it into a decimal number. Let's try it with something similar to that. What if I had the number 3/8? How would I turn that into a decimal number? 3 divided by 8. 8 goes into 3 0 times. But if I add a decimal point here and here, add a 0, bring it down, 8 goes into 30 3 times. If I bring down another 0, 8 goes into 60 7 times. And if I add another 0, I finally get to the end of this problem because 8 goes into 40 5 times. We've got a remainder of 0. Therefore, 3/8 is exactly the same as 0.375. They are the same number. 3/8 is the same as 0.375. Let's try it again with another one. What if I had 2/16 and I wanted to change that into a decimal number? Well, 2 divided by 16. 16 goes into 2 0 times. But it does go into 20 one time. What if I bring down another 0? It goes into that twice because 16 times 2 is 32. What if I bring down another 0? 16 goes into 80 5 times. Exactly 5 times. We're done. 2/16 is the same as 0.125. 2/16 is the same as 0.125. What if I don't trust myself on that? Well, you could take a calculator, and you got to be careful, and you divide 2 divided by 16, not 16 divided by 2. If you do 16 divided by 2, you're not going to get the right answer. 2 divided by 16, the calculator should come up with that answer. But we're practicing long division here today, so we're expecting to see something that looks like that. Okay? Let's try another one. Try another one. But this time, it's going to be something like this. A mixed number, 1 and 1/4. 1 and 1/4. Well, the first thing to note is we're going to break this into pieces a little bit. When we see this, automatically we know the answer is going to be 1 point something. That big 1 becomes this 1 point something. It's really only the 1/4 we need to change into a decimal number. So watch what I do. Again, 1 divided by 4. 4 goes into 1 0 times. But if I continue, 4 goes into 10 2 times. Bring down another 0. 4 goes into 20 5 times. So what does that mean for our answer? If this is 0.25, and we already know that there's a 1 out in front, we can take that 1 and we can add the 0.25 to it, and we get 1.25 as our answer. So this equals this, our 1 and our 0.25, 1.25. Practical example of that, 1 and 1/4 dollars. 1 and 1/4 dollars is really $1.25. Okay? Let's try another one. Try another one. What if I wrote on the board 4 and 1/6? Then I wanted to change that into a decimal number. 4 and 1/6. Well, first I'd write 4 point. And now I got to figure out what the 1/6 is. So I take 1 divided by 6. 6 goes into 1 0 times. But 6 goes into 10 1 time with a remainder of 4. Let's bring down another 0. 6 goes into 40 6 times with a remainder of 4. Oh, 6 goes into 40 6 times. You see what's happening here? This is going to repeat over and over and over and over again, right? So how do I write that as an answer? Well, like I did before, it's just a matter of combining these two together. 4 point something, and we've got 0 point something, right? It's really 4.1666666. Or, as we've talked about in the past, because the 6 is repeating, we put bar notation over the top of the 6. It's really 4.16 with bar notation. Okay? Any questions so far? How about we look at those example problems at the bottom of the page, the green dot problems. Let's look at 3/4. 3/4. How would I change that into a decimal number? The top number divided by the bottom number. 4 goes into 3 0 times, but it goes into 30 7 times. And if I bring down a 0, it goes into 20 5 times. And that makes sense if you think about it. 3/4 of a dollar, 3/4 of a dollar is 75 cents. So 3/4 is the same thing as 0.75. How about a negative fraction? Should that freak us out? Nope. If I have the fraction -3/5, and I want to change that into a decimal, 3 divided by 5. We know the decimal is also going to have to be negative. 5 goes into 3 0 times, but 5 goes into 30 6 times, doesn't it? And I get 0.6. I'm sorry, negative 0.6 in that particular case. How about problem C on the bottom of 63, where they have 2 and 1/9? Let's see what we're going to do with that. 2 and 1/9. Well, first of all, I'm going to write the 2 in a point, decimal point. And now I got to think about the 1/9. What happens when I divide 1 by 9? 9 goes into 1 0 times. But it goes into 10 one time, doesn't it? Yep. Uh-oh, bring down a 0. Do you see what's about to happen? It's going to repeat over and over again. It's going to repeat over and over again. It's just going to keep going like this over and over. So, what's our answer? Well, we could write 2.111111, but we're going to use bar notation over the 1 to show that the 1 is repeating. 2.1 repeating. Okay? Oh, let's see. So, go to the next page. Go to the next page. How do we round repeating decimals? That's the top of page 64. How do we round repeating decimals? Well, that's a tricky thing. You'll notice example 3, they're talking about the fraction of 6/11, and they're changing it to a decimal number. Do you see that? It says Chris Wilson won 6 out of 11 games that he started. To the nearest thousands, find his winning average. See that? Example 3, top of 64. So what did they do? They divided 6 by 11, and they came up with this really weird repeating decimal of 0.5454545. Now, in the directions, they wanted to round to the nearest thousands. That's what it says. So if I write this on the board, where is the thousandth spot? This is tenths, this is hundreds, this is thousands. They want us to round to the nearest thousands. But in order to do that, we have to look at that digit and the digit to the right. What would we round 54 to? I'd round it to 50. But I only want to show these 3 digits. I don't want to go any further than that. So the answer ends up being 0.545. I'm not going to change that 5 because it stays as a 5 because I would round 54 down to 50. I wouldn't round 54 up to 60 in this case. So that's rounded to the nearest thousands. But what if this was an 8 instead of a 5? It's not. But what if it was? How would I round that to the nearest thousands? Well, I would change this to a 6. Why, Mr. Ponko? Well, I would round 58 to 60, right? And the 2 digits in front of it are still a 5 and a 4. So I'd write 0.546. 0.546. So if you're rounding to thousands, the third place value, you got to look at the next digit over to determine how you're going to round that. Originally, we know this was a 4, so that means this becomes a 5. Let me ask you this though. What if somebody said, instead of rounding to thousands, what if they said round to the nearest hundreds? Where is the hundreds place value? It's right here. And if I'm rounding to the nearest hundreds, that means I'm going to be looking at these 2 digits right here because I only want to show the tenths and the hundredths spot. What would I round 45 to? I'd round that up to 50. And because I'd rounded up to 50, that means my final answer, if I'm rounding to the hundreds place value, is 0.55 because that 4 becomes a 5. Make sense? Okay. Hopefully. Look at example 4, writing terminal decimals as fractions. In other words, now we're doing it the opposite direction. Before we were changing fractions into decimals. Now we're changing decimals back into fractions. This is actually a little bit easier, especially when they're terminating decimals. Let's start with something easy. Here's a terminating decimal, 0.7. It occupies the tenths slot, the tenths place value, so the answer is 7/10. No big deal, right? Can we simplify that? No, we can't, so we're done. Let's try another one. What if it's 0.14? That's occupying the tenths and the hundredths place value, tenths and hundredths, so I write it as 14 hundredths. Can I simplify it? Yeah, yes. Divide by 2, divide by 2. There's my final answer, 7/50ths, right? What if it's 0.369? Well, I'm occupying the tenths, the hundredths, and the thousandths spot. So I'm going to write it like this. Can I simplify that? No, I can't. So I'm done. How about something like this? 0.4513. I'm occupying the tenths, the hundredths, the thousandths, and the 10,000ths place value, and so I write it like this. Can I simplify that? Nope, I can't, so I'm done. How about this one? 0.5220. I'm occupying the tenths, hundredths, thousandths, 10,000ths, and 100,000ths place value. So I write it like this, over 100,000ths. Can I simplify that? Yeah, I can. Both of those are at least divisible by 2. If I divide by 2, I get 50,000 on the bottom. On the top, I get 26,104. Uh-oh, I can simplify that even more. Let's divide by 2. I get 25,000. And on the top, I get 13,052. Oh, I can divide that even further. 12,500 on the bottom, and on the top, it's 6,526. And we can keep going and going and going here. About 6,250 on the bottom, and on the top, 3,263. Hey, finally. I'm pretty sure this is simplified form there. Don't worry, you're not going to have weird problems like this where you're going to have to simplify it that much. Sorry about that. I cut that off. The final part of this is, what do we do with repeating decimals? What do we do with repeating decimals when we want to change them into fractions? Like, let's say, for example, we had something like 0.2 repeating, and we wanted to change this into, into a fraction. Well, if it was 0.2, we'd write it as 2/10, or simplified form, 1/5. But this is a repeating decimal, so the way we do it is we just simply put it over 9, believe it or not. 0.2 repeating is 2/9. 0.3 repeating is 3/9. 0.4 repeating is 4/9. 0.5 repeating is 5/9. That's all you gotta do with those, okay? Now, what if the repetition is 2 digits? Don't panic. If I have something like 0.23 and the repeating bars over both of them, then I write it like this, 23 over 99. Or what if it's, say, 0.17 and the repeating bars over both the 1 and the 7? That's 17 over 99. Notice, if it's a 1-digit repetition, it's over 9. If it's a 2-digit repetition, it's over 99. Okay? Hopefully that helps you through this. Thank you, folks. Have a good day.